In my preparation for interview, I came across this question from a YouTube video by Jamin Shah. I'll link his YouTube in the description below. And I just thought the solution was very interesting, so I wanted to share it with you guys. So suppose we have y equals x squared plus alpha x plus beta, where alpha and beta are uniformly distributed between 0 and 1. So essentially they have equal probability between any of those real numbers between 0 and 1. We want to find the probability that y has no real roots. Okay, well, what is the condition for a quadratic polynomial to have no real roots? Right, no real roots implies complex roots, implies the discriminant is less than 0. So what's the discriminant of our quadratic here? Our discriminant is going to be equal to alpha squared minus 4, well, lots of 1 times beta. So this is just going to simply be alpha squared minus 4 beta. Why does that work? Well, if we have just a general quadratic here, plus c, oh, come on, plus c equals 0, with here a, b, and c are all real constants. Okay, we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a here. And so alpha is real, 2 alpha is real, and also a is non-zero, so that we don't have any divisions by 0, and also so that this is a quadratic. So the only condition for x to be real is that this here is not real. This here is complex, and the only way for that to be complex is if b squared minus 4ac is negative, right, is less than 0. And so we have b squared less than 4ac. In this case, our b is alpha, our a is 1, and our c is beta. So that's how we got this condition here. So really what we're asking is the probability that alpha squared minus 4 beta is less than 0. So that's equal to the probability that alpha squared is less than 4 beta, or the probability that alpha squared over 4 is less than beta. Interesting. Well, now that I have this condition, I need to think about how I can use that alpha and beta are uniformly distributed between 0 and 1 to sort of figure out what this probability is going to be. Now, here's the key insight. If I draw a graph of, if I have a beta axis and an alpha axis here, and here's 0, I'm going to have 1, I'm going to have 1. I know that any pair alpha beta must lie within this square, right? Any pair alpha beta must lie in this square, simply because they are uniformly distributed between 0 and 1. So for example, this point here could be, I don't know, 0.68743 ... whatever, and this here might be 0.794 whatever, right? So within this square, this describes all alpha and beta between 0 and 1, all possible pairs alpha beta between 0 and 1. And now that I'm looking for this condition, that alpha squared over 4 is less than beta, well, if I sketch the graph of beta is equal to alpha squared over 4, so that's going to be some quadratic here, but it's going to be divided by a factor of 4, so it's going to be increasing ever so slightly, sort of like this. And let me just get rid of that cross for a second here. I guess let's get rid of these numbers, right? Now, if I consider this blue area here, okay, and this is my graph, beta equals alpha squared over 4. If I find where beta is greater than alpha squared over 4, so that's going to be all of this part, right? And I divide that by the total area, which in this case conveniently is 1, right? I will find the probability that beta is greater than alpha squared over 4, given that alpha and beta must lie between 0 and 1. Okay, so I'm going to have probability that, I'm going to write it like this, beta is greater than alpha squared over 4. That's simply going to be equal to, well, to find this blue area here, I'm going to have to do 1 minus the integral from 0 to 1 of alpha squared over 4 with respect to alpha, and divide that by 1. Okay, because this here is going to give me my green area, this 1 here. That's simply doing 1 times 1. And then my integral here represents the blue area. And so if I compute this quickly, we're going to have here, okay, so this is 1 minus the integral from 0 to 1. Let's bring that factor of a quarter out there. Simple power rule stuff here. So this is going to be alpha 3 over 3, 0 to 1. 1 minus 1 over 4 times 1 over 3 minus 0. And so this is going to be 1 minus 1 over 12, which is simply 11 over 12. A really interesting problem here and a really nice result. So it turns out that most of the time you're actually going to get complex roots. So that means if you pick any random alpha and beta, right, and you draw out any alpha and beta between 0 and 1, and you decided to draw that graph out in Desmos, and you see, okay, does it have real roots or not? 11 times out of 12, it's not going to have real roots. I think that's really cool. Let me know what you think about that question in the comments below, and let me know if you attempted it. And also let me know if you have any other methods of solving this. Okay, catch you in the next one.